Okay, so hi everyone. So I'm Kate Baker. I'm Head of Communications for Research and Publishing Services at Springer Nature, and I will be chairing today's session. So today's session for our virtual Frankfurt Book Fair is going to explore how artificial intelligence and machine learning have been opening up science. I'm joined today on screen by Amye Kenall, who is VP of Products and Publishing at Research Square, who in her role leads the product, publishing and UX design divisions there, and in doing so balances the performance of traditional product lines with establishing more disruptive AI-driven and software as a service product lines. We're also joined today by Rocco, who has recently joined Springer Nature as manager of our books publishing solutions, but throughout his career has worked on various national and international projects in different areas of AI. He's also a published scientific author and has written many papers on machine learning, human-computer interaction, Industry 4.0, which I'm sure you'll tell us about, Rocco, natural language processing and process intelligence. So I think you'll all agree that they're both very qualified to talk to us today about how AI and machine learning are both being used within the publishing sector and the wider impact that this is having on open research and open science. So today's session will be split up into 3 sections. I'll be handing over shortly to Amye and Rocco, who are going to take you through a short presentation each, and then we'll move on into an open discussion. So please do put any questions that you have throughout the sessions into the chat box, and then we will pick that up towards the end. So without further ado, Amye, I'm going to go on mute and hand over to you.
Thank you. So if we can go to the first slide. Hi. Okay, so like Katie said, my name is Amye Kenall. I am from Research Square, and my talk today is really going to focus on a very specific area of open science, and that is open access, and how what we are doing with AI is affecting that. So at Research Square, we're an author solutions company. If you haven't heard of us, we offer researchers tools and services to help improve their manuscripts, as well as other help throughout the research lifecycle. Our mission is to make research faster, fairer, and more useful, and we do this by providing researchers with tools and services to improve, share, and promote their work. Next slide. So to break it down a little bit more for you, there are 2 main brands, divisions operating at Research Square, and that is at Research Square Company, and that is the Research Square division, which is far more, it's experimental, it's developing more software products, it is more like a sort of innovation hub. And then the AJE side, this is our more established, oldest arm of the business. We offer language editing and mostly human-delivered services. Now, what we had noticed, and so both of these really speak to our mission as a company to make research faster, fair, and more useful. But we do know that when you are delivering a service, a human-delivered service like AJE, there is a limit in your reach, right? And your reach can only extend as far as the researcher who can afford your service, right? The few hundred it takes to have a manuscript edited by a professional editor. And so we started asking ourselves as a company a few years ago, can we extend our reach using machine learning? Next slide. And so for the past couple of years, we have had a digital editing tool. We developed this tool, well, a range of AI tools really, but speaking to the digital editing tool, we developed this tool using all of our before and after edited manuscripts on the AJE side of the business, and as well as data from other places. And in doing that, we're able to develop a very effective, highly accurate language editing tool specific to research content. Now, you might ask, and so we've developed a few tools like this, right? Some with, for example, translation, everything very much geared to scientific research. And we're continuing to develop more every time we decide to develop a new product. We are asking ourselves, can we do this with machine learning first? Still, how does this affect open science in the long run? Yes, this helps extend our reach with AJE, but how is this actually going to affect open science? So next slide. So at the end of 2018, we launched a preprint platform called Research Square. You might have heard of this. This platform is now the largest preprint platform, publishing more every month after Archive. It also is the fastest growing preprint server. Now, preprint servers are sort of our main, this preprint server is our main avenue into open access at our company. And next slide. But we've seen a similar problem that we saw with AJE. So preprinting, as we know, if you want to publish your manuscript open access, there are really two avenues. You can preprint your work in some form, usually before it's gone out to peer review. This is free. You get a DOI, so you can be cited. At a few preprint servers, including ourselves, we'll give you a beautiful HTML layout. And you're increasingly getting the very similar levels of indexing as you would get at a journal, but you're missing some key elements. For example, the review of the science, and I'm including checks on your statistics, methodological rigor, etc. Any kind of review of the science and any kind of review of the language. To do that, you have to go gold away, and that costs, of course, on average around $2,000. So what this does is really creates two divisions within the open access world. One level of quality for those researchers who can afford gold OA, who are well funded, who come from institutions that can afford it, and another for those who cannot afford it. And it also creates this division between what can be trusted, that is open science, and open science that cannot be trusted. Next slide. So what we're aiming to do with those AI tools that we developed is to, again, use them to extend our reach in open science. If we aim to layer those tools onto our preprint server, and we are starting to do this already. And by layering those tools onto our preprint server, allow people to increase the quality of their preprints and help to validate their preprints before they actually are published. Now, we're a very long way from AI having being able to peer review on a level of a human. That's not what we're saying at all. So I'm talking about things like, for example, language tools. We can, our digital editing tool, for example, it can edit to the level of a basic copy edit that one might get at a publisher. But we're also looking at other tools, for example, that look to the science more. And we've experimented with a couple of these partner tools, and are also building our own tools. And none of them are ready, but the idea is that we can layer these tools onto a preprint and start to validate it, start to make all open science research trusted, and not, or at least show how distinguish how it can be trusted. and not just for those researchers who can afford it. Next slide. So when we ask ourselves why AI at Research Square, we choose to utilize AI in order to allow us to really extend the reach of our mission, whether it be just through our products or through open science generally. And that is me. Thank you. Next slide.
Thanks, Amye, for that. So we're now going to hand over to you, Rocco.
Thank you. Thank you, Amye, for the presentation, and thank you, Katie, for the introduction. With my presentation, I'd like to define what is open science and for addressing a specific question. Next slide, please. The question I want to address is how can AI help us to open up science? For doing this, I will present you some of the activities, approaches, and tools that we are at the moment investigating at Springer Nature in this field. But first of all, we should start with defining what is open science. So, what is open science? Next slide. Open science is a systemic change in the way science and research is done. The term open science is a very general and umbrella term, which includes a huge range of movements, from the open source movement to the open access movement. And in the future, we will probably have a further movement taking part to this great activity. The open science comes from the necessity of offering a solution for going beyond the barriers that limit the dissemination of scientific data. For doing this, the open science has specific targets. One of the main targets is to share practice for making scientific research transparent and accessible, and for implementing research activities by means of collaborative networks. Next slide, please. So how can AI help us to open up science? Next slide. So artificial intelligence are systems that perceive their environment and take actions that maximize their chance of achieving their goals. So if we want to use artificial intelligence tools and systems for supporting the open science paradigm, we need first of all to understand what are the goals of the open science movement, and of the in order to be able to align the goals of the open science paradigm with the goals of the artificial intelligence tool that we want to develop. The main goals of the open science movement are four. The first is making it easier to publish and to communicate. Then we have the goal to removing all barriers for sharing scientific research. The goal of providing transparent and accessible knowledge, and the goal of supporting collaborative networks. In the next minutes, I will show you, I will make you a rapid overview of several activities, approaches, and tools that we are investigating, or that we already developed at Springer Nature for addressing each of these specific questions related to these four goals. Next slide, please. For reaching the goal, the open science goal of making it easier to publish and communicate, we developed several tools for helping, for supporting and making life of our editors and our authors and readers easier. Artificial intelligence offers a huge opportunity for generating smart tools, and we made great experiences at Springer Nature. This is a list of some of the activities that we started at Springer Nature. Some of them are tools which are already in use, developed and in use, and some of them are approaches that we are investigating at the moment. For instance, the book performance estimation tool, it's a great tool that aims at making the life of our editors easier. It's a tool based on machine learning for predicting the potential success of the book before that the book is written. Then we have several auto summarization approaches. These approaches have been used for developing tools which use auto summarization. Auto summarization is a typical use case of natural language processing, and machine learning helps us a lot with this task, and we are very active in this field. Then we have data science and data analytics, approaches for identifying and predicting emerging areas of interest for researchers. We developed, we investigate different approaches for this purpose, and we have a great tool which is Send Insights, which makes possible to reach this goal. It is a very complex tool which has very different features, but one of them is this. Then we have natural language generation approaches. We use GPT-3 for generating new books idea. This is a very new approach, and GPT-3 is probably the best solution for this. And we are investigating this kind of autoregressive networks. Then we developed language check tools, keyword to sentence and sentence to keyword approaches, and other typical natural language processing use cases, and tools for manuscript editing. Next slide, please. For reaching the goal of removing barriers, which is an important goal for open science, but in general an important goal for our society, we developed different tools, and we are investigating different approaches. Let's define barriers. Our tools and our approaches are able to face very different typologies of barriers. We have tools for facing the linguistic barriers. So auto translation tool. We made a collaboration with DeepL, which is probably the best auto translator, and we developed tools for our authors for auto translating with machine learning large text part. We have approaches for machine-generated books, for creating machine-generated books and machine-generated literary overview, and these approaches can help us to remove the barrier of the access of science for non-professional, because this kind of book can address non-professional very easily. We have approaches based on recommender systems for workflow suggestions and sharing best practice, and other approaches for accessibility, such as text-to-speech and video transcription. Next slide, please. For reaching the goal of promoting transparency in science, we are also very active. We have some tool which is already available, and we are investigating other tools. We have tools for plagiarism check, which is a very important topic nowadays. We have more in general approaches for research integrity, for promoting research integrity, like for instance tools for identifying if images are copied or reused in a non-common, in a non-proper way, and for this is machine learning very useful. And then we also have approaches for bias recognition. Bias and stereotypes are important topic today in for our society, and in science it's also something we have to address, and we already have some approaches for addressing this. Next slide, please. Probably the main goal of for certain aspect, the main goal for open science is supporting collaborative networks, and in this field we are very active. We have, for instance, developed a tool which is paid. It's a tool for identifying new potential authors. Similarly, we have tools for identifying peer reviewers, for identifying editors and other stakeholders who could be related to specific topics. And we are testing also approaches for using sentiment analysis in order to identify communities or a group of researchers online. And this could help everybody to support networks and to make networks more collaborative. Next slide, please. So, as you saw, it was very rapid overview of some of the approaches and tools that we developed using AI for supporting open science, but not only. It is for me very important to remark that AI is a very useful, a very powerful tool, but we do not have to forget that the human must remain in the middle. That we have to have focus on the user. It's important to, for us, it's important to create the best environment and the best tools for our authors, for our editors, and for our readers. And never forget that artificial intelligence is a means and not an end. So thank you very much.
Thank you very much for that, both Rocco and Amye. And I think, Rocco, the point that you end on is a very key and important point that I think Amye picked up on as well, is that the machine doesn't necessarily replace the human, which I know is a lot of some of the questions that we've had in are definitely to that effect. So we've had a couple of questions that have come in, which I will go through shortly. But first of all, I wanted to ask you both. Throughout your presentations, we've talked through the various tools that we are both at Springer Nature and Research Square implementing that are using AI. But I'd like to kind of step back a little bit from that, if I may, because AI is quite a relatively new field within the kind of publishing space as far as the history of the sector goes. So how do you go about identifying those areas where AI could be influential or useful? Because obviously a lot of this stuff actually happens behind the scenes that, you know, your author or your researcher or your editor may not necessarily see or be aware of. So how do we go about identifying those areas where it can play a role?
I mean, I think from the Research Square side, it's a really simple answer. We ask ourselves, you know, whenever we see a new job to be done from the researcher that we want to address, we ask ourselves, how could we do this through machine learning? Could we, right? In some cases, you just don't have the right data set. You can't, right? But it also just puts it on our you know, sort of parking lot of this we want to do with machine learning. We just can't right now. Maybe if we find the right data or the right partner, we can. So that's what we ask ourselves for every new product that comes up. For sometimes it becomes really obvious you can improve something through machine learning. For example, the language editing actually came about to improve operational efficiency. It was an obvious one. We had an incredibly valuable data set and we could do it.
I can definitely understand what you mean. And I want to add just that, as I mentioned in my presentation, we must not use AI. AI is an opportunity. Sometimes it's the best opportunity, sometimes not, and it's good. But what is important is also to understand what are the current opportunities with AI, so that we can use we can address these opportunities. I think the greatest opportunity, that the biggest opportunity that the AI offers is the possibility to generate new disruptive business models. And in this sense, I think this could be very useful for open science as well. Without AI, open science could probably be seen as a threat for classical publishing companies. Instead, it is an opportunity, and a huge opportunity. So for me, it's important to focus on the possible opportunities, and I see a lot of opportunities. New disruptive business models, better processes, analyze and predict our data, and much more. And if we have a clear idea of our opportunity, then we can get the best from it.
Yeah, I suppose as well it goes back to some of the points that both of you made about almost that kind of transparency in the publishing service, you know, coming through and still within, you know, what the last 18 months has thrown at us in terms of the pandemic. You know, there is a need for research quickly, efficiently and accessibly, and, you know, having tools such as AI and machine learning that behind the scenes can help our researcher community, you know, get published quicker, Amye, as you say, you know, through the kind of preprint service, or see transparency behind the scenes with the data sets that we've now got accessibility to. You know, it's all about building in efficiencies within what can be traditionally quite a cumbersome process to make sure that we're getting access to research as quickly as we can. So nice point about the opportunities, Rocco. So one of the other questions that's come in as well, and I know, Amye, you picked up slightly on it when you were talking about the kind of trust and peer review process. Where do you foresee the kind of biggest challenges with AI and publishing then? Is that on the kind of researcher engagement side of things? Is that on the publisher side of things in terms of data privacy, the data sets that you've got? You know, what are the challenges that you're seeing in introducing it at the moment?
Sorry. Having large enough high quality data sets, that's the biggest challenge. So there has to be, I keep saying to my team, a big opportunity with AI, I believe, is to improve science. So we have a tool that our tool can get 70% of what a human can get. That's pretty good, right, for a tool. And so we can do this with language. Can we do this with science? Can we improve science? And there are a lot of tools out there that are kind of starting to do it, and we've tested them and played with them, and there are a lot of problems with them, right? They work on one particular type of article, you know, or and so I think the biggest challenge is how can we improve research with AI, right, with machine learning? And it's hard to do at a manuscript level because there's a lot of unreproducible research out there, quite frankly. There's nothing to train on, right? This is part of the problem, and because it's so field specific, that's, I think, our biggest challenge.
I definitely agree. I think there are, we probably should divide into like technical, pragmatical challenges and like high level, let's say, challenges. On the technical, pragmatical level, data set, the lack of data sets, of good data set, and also the fact that that we have some very good language models. For instance, autoregressive language models like GPT-3, which are very good, but trained mostly on non-specific text, on generic natural language text, and not on scientific languages. Scientific language is completely different, and we have at the moment a lack of language models for scientific tests, and I can imagine in the future we will not have this lack anymore. We will solve this solution, and then at that point we will have another problem, which is the lack of specific language models for each discipline. If you think about the language model for physics in English, it's very different from the language we use in law in English. So yeah, this is a very important point. And but something technical, I would also add something on let's say a higher level. Also ethical aspects related to AI must be addressed. For instance, I mentioned briefly before something about bias and stereotypes, at the moment AI systems tend by definition to believe and to use bias and stereotypes. In this sense, the big misunderstanding that we do is to believe that when we use an AI tool, we are asking to the AI tool to get the truth. But we do not get the truth from an AI tool. We only get an answer that for the machine, for some reason, fits and can be put in relation to the question, which is a huge difference. And it's something which is difficult to be understood if you don't really understand if you don't really know how AI or machine learning, for instance, works. So in this sense, another challenge is also the difficulty to explain and communicate what AI is and what are the possibilities. Yeah, but I'm very optimistic about it.
That's good. And actually, Rocco, what you've just said there kind of pulls into another question that we've had in, quite a practical question, actually, saying, you know, if I'm interested in AI development for my research or how I can use it in the research I'm doing, where do I go, and what kind of conversations should I be having with my publisher or my research faculty?
Can you please? I didn't really understand the question. What do you exactly mean?
To know more about how AI can support the work that they're doing, the research work that they're doing in labs. So I'm presuming it's where can I have those conversations? Who do I need to speak to find more about what AI, you know, capabilities are available for me to use?
Mm-hmm.
And maybe it goes back to the point, you know, you both made earlier, that a lot of it does kind of happen behind the scenes in tools that we're already using. But yes, just I suppose wanting more of an open conversation about it to learn more and understand more what AI can do.
Mm-hmm. I think it's important to know the possibilities, to being up to date with opportunities that AI offers, and in this sense, probably also specifically related to the to open science and the publishing industry. It is important to understand the role of AI. What kind of role do we want for AI? Do we want to reach a robotic process automation paradigm where AI writes everything? And no, I mean, we don't want it. And this is just one starting point. And then more so focusing on the importance of AI for supporting human activities, which is a different approach. And it's important to focus on it. And so if I think about the roles of AI technologies in our sector, I think it's important to, for me, thinking about the future, it would be a huge result if we could think about AI as a teacher, a kind of teacher that explains us what we are not able to understand. So
Yeah.
go in the direction of explainable AI in the sense.
So I think we've had two more specific questions coming that I think probably will sit across both of you. The first part of that question is about transfer learning. So do you see transfer learning as a promising example of looking at small data approaches versus big data analysis? And then connected to that is the thought that, wouldn't it actually make more sense to develop tools that are more specific and specialized to handle specific types of paper, fields of science? Or is there a wider vision of developing general tools that can be applied to many products? So there's two parts to that. So the first part about transfer learning and small data versus big data, and the second part about product development.
Shall you go for the first, Rocco, and I'll take the second, then it sounds like.
Yeah, I think both approaches are necessary. We have to consider both the whole picture. I mean, big data and generic tools, but also specific tools. I think in the future we will have a lot of very specific tools, as I mentioned before, improving language models for specific disciplines. We will probably have very specific AI systems and very specific AI tools, but at the same time, generic systems will be always needed. It depends on the problem we have in the end.
Yeah, I would agree. I think it depends on the problem. There is always very, my experience working with research communities are, every field is very specific and unique in their own way. I used to work a lot around open data, and the problem was always, the biggest problem in that is it's different for every field how to standardize data, right? And it's a similar thing, I think, with just natural language as well. For our digital editing tools, actually not one model, it's a collection of machine learning tools, and one of them does identify at a very detailed level the subject area and takes that into context. So we already do that with language editing. I think there will be, you already see this with, so for example, if you go to at BOSC or ISMB, that one of the bigger computational biology conferences, there will be very niche software products being developed, and I think this can possibly come out of the research community themselves as they learn how to utilize machine learning as well, in ways that maybe don't make sense for publishers who are trying to address an entire market to really invest in, but more just integrate with.
Yeah, I would also add something, and I agree definitely. And it's also very interesting to see how very niche specific solutions, like I think about the genetic algorithm in biology, which has been developed for biology. It's interesting to see how it's been useful or also in very different fields. So I also would foresee a kind of contamination, so a kind of a very specific discipline-related development and a consequent contamination between different disciplines, as we already saw in a smaller scale.
Great. Thank you very much, both. We're coming up to time shortly, so we've had a bit of a crystal ball question, which I think both of you have answered in various forms as we've gone forwards. But essentially, 5 years' time, what does AI look like? How are we using it? Maybe Rocco, this is for you with all the research that you've done and all the work that you've done with the German lab as well. You've seen how it's progressed.
It's as 5 years. It's a huge amount of time for machine learning. Think about what we could do 5 years ago or 10 years ago, and what we do now. I would come back to the question about the role of AI technology. I see in particular two main roles for AI technology for the future. And the first is the development of generative models that generate outputs. This is something we saw in the field of generation of images. It's something very common now, but it's been investigated also in other fields, like in text or for aggregated metadata. But I think I think AI will have in the near future the important role of developing new models, like of generating models that generate output. And the important thing is that I really believe that we will use this output as I believe that each output we get from AI could be used from a human as a new input. And this is a slightly different paradigm. And I mean, I'm very fascinated about it. And I think it will happen, like conceiving the AI technology as a generative model for getting input instead of output, and then we start with this input for reaching other goals. But this is also in the line of this human-centric AI. And then the second role is also related to this somehow, as making AI our teacher. Explainable AI is a really important reality, and it will play an important role in the future. There are things we cannot understand, and AI can understand. So in this sense, the challenge of letting AI teach us something.
Sounds good. And anything from your side, Amy?
Yeah, and I was thinking that this morning. I have a 4-year-old, and whenever she wants to know anything, she always just says, "Hey Google, what's?" I thought, like, this will be how she knows to learn. right? Whereas that it's cumbersome to me to have to say that sometimes. Anyways, I think, well, obviously the tools will drastically improve, right? The amount just in the past year that we've seen our own tools improve is, slightly scary. I think it will just very much disrupt some industries, right? There will be some things we just don't need humans for anymore. The industries will entirely shrink, and that's okay. So I think that is the biggest thing we're expecting as a company, and for it to improve in ways that Rocco explained, to allow us to create even new markets that weren't there before.
So embrace change, I think, is the underlying piece from both of you. That's great. We are up to time for our slot today. So just to say thank you both to you very much for joining today and sharing all of your insights, and to everyone who has tuned in to listen to the session. If there are any follow-up questions, I'm looking to see if Billy mentions that we've got an avenue to do that, but obviously do feel free to drop them to us, and we can pick them up separately and offline. And Billy has just told me, yes, there is a survey, so you can do that. But yeah, thank you very much to everyone, and enjoy the rest of your days.
Thank you.
Thank you.
Take care. Bye.
Bye. Thanks.